Now in this video we'll be getting into some of the basic configuration of point-to-point GRE over internet, and then we'll also implement some routing protocol over it. And the main intention of this lab here is to ensure that my 192.168 1.0 network should communicate with 192.168 2.0 network, and for that we are going to build one virtually a point-to-point connection between router 1 and router 2. So that's something what we are going to build, a GRE tunnel between router 1 and router 2. So the first step, let's configure some point-to-point tunnel. So I'm going to build one logical GRE tunnel between router 1 to router 2. So let's get into the command line. I already have a reachability between router 1 to router 2. And again, let's go and verify. From the router 1, I should be able to ping to router 2 public IP address. Now we need to ensure that before you build a tunnel, there should be reachability between the GRE source, tunnel source and tunnel destination addresses. I already have reachability based on the default setup configurations. Now I want to build a tunnel, so I'll go to router 1, and the configuration is very simple. We need to create one logical tunnel interface, and now we need to define tunnel source, and the tunnel source can be IP address. Either we can define the IP address of 15.001, or we can also define the name of the interface, like we can simply say S0 by 0. So both works fine here. Let me go with IP address here, 15.001. So I'm going to type the IP address of 15.001. So 15.001, and the tunnel destination, I'm going to use it as 25.002. That is router 2 public IP address. And after that we need to define some IP address for the tunnel. So I'm going to use the IP address as 10.0.12. network. It can be any private address, and I'm going to use it as 10.0.12.x network with /24 subnet mask. I'll be using 1 on the router 1, and I'll be using router 2 will be 2. Done, that's it. So the same configurations you can go on the router 2 as well. On the router 2, we need to create one tunnel interface, and that tunnel interface can be any number. It is just locally significant, no need to match on both the sides. And then I'm going to define some tunnel source. Now the tunnel source I'm giving S0 by 0 interface or IP address. In my scenario, I can give 25.002, and the tunnel destination will be 15.001. And then we need to define the IP address. I decided to use 10.0.12.2 on the other side. Now you can see the tunnel interface is up. We don't need to give no shutdown command because it's a logical interface. So if I give show IP interface brief, I can see the tunnel 1-2 interface is up, and I should be able to ping to the opposite side of the interface, that is 10.0.12.1, as if it is more like a point-to-point connection. So we can ping from this point to this point as if it's a point-to-point connection, and that's it. So we are done with the first step, configuration, and the configuration is very simple. Now the next thing, we want to ensure that the router 1 LAN users, that is 192.168 1.0 network, should be able to communicate with 192.168 2.0 network. Now to make that possible, we need to configure some routing protocol. Now GRE allows you to have some routing or multicast traffic to send over it. So I'm going to run EAGRP. I'm giving no auto summary and advertising the LAN interface, that is 192.168 1.0 network, and I'm advertising the WAN interface, that is my 10.0 network, the GRE interface. Now the same thing I'm going to do it on the router 2 as well. On the router 2, I'm going to say 192.168 2.0 network, which is in the LAN, and then 10.0 network on the WAN. Now after some time, I should see the neighborship established between the router 2 and router 1, and if you try to verify the neighborship, show IP EHRP neighborship, you can see the router 2 is forming the neighborship with 10.0.12.1 over a tunnel interface, that is 1-2 tunnel interface. And then if you verify the routes in the routing table, I can see the route of the router 1 LAN, and I can ping to 192.168 1.1 source from my 192.168 2.2, which is my LAN interface, as if it's like a directly point-to-point connections. Now the same thing, I should see the same thing on the router 2 as well, and I should be able to ping. Already we tested that. Let me try trace 192.168.2.2. I can see it shows as if it is directly going to 10.0.12.2. It's directly going on this interface. But actually what happens is when you're sending any packet, let's say this is my IP packet here, which is including the source IP address is 192.168.1.1, and the destination address is 192.168.2.1. so that is your actual IP packet. So once it is moving through the router, once it reaches the router is going to add some GRE header that contains the source IP. The source IP will be 15.0.0.1, and the tunnel destination IP, and the destination IP will be 25.0.0.2, and the actual forwarding of your packet happens based on this outer header, which means it will simply send it to 25.0.0.2, and then it reaches, because based on the routing, to reach this, the next stop is 10.0.12.2. That's something what we have given, and this will go over tunnel interface, tunnel 1.2. And then tunnel 1.2 says, okay, if you are going via tunnel interface, then you must add this header, and the source address will be 15.0.0.1, and the destination is 25.0.0.2. And once it reaches the router 2, it is going to remove the outer header, and it will forward as a normal based on this one. So that's how we can configure a normal basic point-to-point tunnels. And that's something what we did. We did the configuration of point-to-point, and then we have implemented some routing protocol. Like in this case, I'm using EHRP to have reachability between the router 1 and router 2 LAN networks.